start recording and then screen share. We go to PowerPoint, share. Oh, this. So this, we were here, right? Yes or no?
Yes, sir.
Okay, so now what we find here, so this group of molecules will be, one group of molecule will be of D configuration and another will be of L configuration. So all these ribose, arabinose, xylose, lactose will be D, and another aldopentose will be having, four of them will have L configuration. So that makes it total 8. So similarly, when we go to aldohexose, what will happen? Aldohexose, there will be 16 structures. Half of them will come with the, half of them will be there with the D structures, and half of them will be having L structures, right? So 8 of them. So 2 will come from here, 2 will come from here, 2 will come from here, and 2 will come from here. So that will make it 8, and from another 8 will come from here. Now you know the trend. So first of all, I am writing only the name. So allose, altrose, glucose, mannose, glucose, idose, galactose, talose. These are the 8 of them. Here, this allose is positive, means dextro. This is dextro. This is dextro. Glucose is dextro. Mannose is dextro. Glucose is levo. Idose is levo. Galactose is positive, and talose is positive. But all these 8 will have D configuration. So they will have D configuration and this. Now let us see their, okay, we come here. What will be their structures? Already we come here. This is ribose, arabinose, xylose, lactose. From ribose we are getting allose, altrose. From arabinose we get glucose, mannose. From xylose we get glucose, idose, and from lactose we get galactose, talose. Writing down their structures, when we these two which comes from ribose will have this part, this ribose part, 3 of them will have on the right hand side, both of them, and this first one will have OH on the right hand side, next one OH on the left hand side. Similarly here for glucose, you have for this one arabinose, you will be having glucose and mannose, so that will come as that will come with the this part of the molecule will have the same structure in both of them, but the new configuration, first one OH on the right hand side, next one OH on the left hand side. So this way we have. Now if I ask you to, now if you ask me that suppose nothing is there in this, in my front, and if you ask me to write down, sir, to test my knowledge, if you say that, sir, write down the structure of glucose, if you tell me, I cannot do it. But if you give me time, I can do it, but just by following this rule, whatever it is. Now you may say that it's very difficult to remember. You can remember their, first of all, only thing you have to, what you have to remember is their names. How the name? First is glyceraldehyde, okay. Both of them are glycerol plus glycerol. Next, this glyceraldehyde give rise to erythrose and threose. Then comes aldopentose will be ribose, arabinose, xylose, lactose. You have to remember them in this order only. And when you write down the structure, you write down the structure that I've given the way we have to write down. Then aldohexose, when we go, you have to remember like a poetry. Aldose, altrose, glucose, mannose, glucose, idose, galactose, talose. So if you can do this one, you can write down any structure, any configuration, any time, but you will take some time. Got my point? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now the question is, So when we go to aldotriose, glyceraldehyde, tetrose, erythrose, thiose, pentose, ribose, arabinose, xylose, lactose. Hexose will be allose, altrose, glucose, mannose, glucose, idose, galactose, talose. You have to remember them just like a poetry. If you have a practice, you can remember it and never forget in your life. But even then, suppose you say that no, sir, I am not able to do it. I cannot do that one. I don't remember. I don't have that memory power. But even then, you don't have to get disheartened. You can have a solution. What is the solution? To handle this carbohydrate chemistry, to know about their structure properly, you have to remember only one structure, only one molecule. Which is the most important carbohydrate molecule, monosaccharide? Tell me quickly. Anybody? Yes? Tell me, which is the most important?
Cellulose.
Huh?
Glucose.
Which one?
Glucose.
Cellulose.
Glucose. Right?
Glucose.
Glucose is the most important molecule. So you simply remember the structure of glucose, nothing else. How to remember? What is glucose? No. That is the formula. Formula has got nothing. All of them, all aldoxes will have the same formula. Oh, now this is the structure of glucose. How to remember? You have to simply remember the position of this OH group. There are four chiral centers, right? These four chiral centers, the first one OH on the right hand side, next one OH on the left hand side, then again right, then again right. So first, this is CHO group, this is always there, and the last carbon atom is CH2H. So what you have to remember? You have to simply remember it as right, left, right, right. This sentence, right, left, right, means position first one is OH on the right hand side, next one left hand side, then again right hand side, right, left, right. Have you heard? Huh? Write down now.
Yes, sir.
Right, left, right. If you can remember this, you can never forget structure of glucose. We come to now. We have to stop quickly because your next class is there with Ganguly sir, right?
Yes, sir.
Okay. So I'll stop within 5 minutes. Now structure, if you remember glucose, now you see the structure of glucose, right, left, right. These are the position of the OH groups, right, left, right. The first one is OH group, and other thing you don't have to remember, simply remember glucose. And what is glucose? This is D plus glucose. What is D? D is that configuration. This OH group is on the right. All the structures having this OH group on the right hand side is your D structure. Plus is means what? It is a dextrorotatory compound. So it is plus. And this is glucose name. And you have seen all these 16 names will be there. There will be 16 different structures. But with respect to glucose, we remember the other structures. What is the second molecule which is very important in case of carbohydrate? Anybody who can tell quickly? Second molecule? Yes.
Fructose.
Huh?
Fructose.
Fructose, right? So when you remember glucose, fructose is nothing but a ketohexose. So ketohexose is this one. Just see. This is, remember glucose. What is, there will be a ketonic group. So ketonic group will come in the second carbon atom. So once it comes ketone here, this becomes OH, but this will become CH2H and it will lose its asymmetric character because this is not chiral center. And this part of the, this other three carbon atom remain as it is, same as glucose. You find here, you see. So you just remember glucose, you get fructose. Only thing, what is the relation between glucose and fructose? You remember it. Another structure is mannose. Mannose and glucose, what is the difference? Difference in carbon number 2. This OH group, it is right hand side in case of glucose, it is on the left hand side in case of mannose. Another structure which is important is galactose. Galactose is also important. So what is the difference? The difference is in the carbon number 4. This is carbon number 4. 1, 2, 3, 4. So in 4, this in glucose it is OH on the right hand side. In fructose it is on the left hand side. So that's all. So if you remember glucose, what is glucose? How to remember? Right, left, right, right.
Yes, right.
Others, you have to simply remember their relationship. How to get fructose, how to get mannose, how to get galactose. And another very, very important biological molecule is ribose. You know, it is there in the nucleic acid. So ribose, you have very simple. It is a aldopentose, but aldopentose, and there are 3 chiral center, and all 3 each group are on the right hand side. So it's very simple to remember. That's all. If you remember this many structures, you can do anything in the carbohydrate chemistry. No confusion in the structure. So with this, we end our class today, and next will be having a next class. We'll continue from here. Again, have a recapitulation. You read, and I'll be giving a task in your Google Classroom. You, all of you join. Those who have not joined, you join it, and I'll give you the Google task in the Google Classroom. And ketohexose, sorry, aldoketose, all the structures you must write yourself from any source and submit it to me in the through Google Classroom. So with this, we end our class, and then we you will join the next class with Ganguly sir. So I stop sharing, then I end my meeting. So
Thank you, sir.
So all right, but then you join on time in time. Today I find there are some. How many are there? There are some what is called. There are some 37, 38 participants. All right. So let me take a picture out of this, and then we'll be having our next class. Okay, so, okay, we meet on Friday. All right. So thank you very much.
Okay, sir. Thank you, sir.
And read whatever I have told. I'll pass on the information later on, but I'll give some question also to
Okay,
Google
sir.
Classroom. Okay.
Okay, sir. Thank you, sir.
Okay, sir.
Okay, bye.
Sir.